about spiders and snakes. Last week, we did talk about spiders and snakes, and these two very large animal families use venom, but they use it differently. Spiders use venom to incapacitate, and snakes use it to kill. Spiders evolved as soon as insects did, around 400 million years ago. Nature doesn't leave food on the table. As insects proliferated, spiders figured out how to get them. Venom glands were present early on, probably in the common ancestor of all spiders. Silk production was also present in the common ancestor. Silks enabled early spiders to build earthbound snares as well as shelters and diving bells and other things. Insects didn't fly at the time, but spider silk trapdoors, snares, pulleys were so effective at basically killing these ground dwellers that the insects became able to fly. They developed or evolved that way, and that's when aerial webs evolved, the ones that we're so familiar with from an early age, if you've read Charlotte's Web. The spiders also run fast, have powerful limbs for their size. They can jump and float in the air. They use all of these tools to capture prey. The more kinds of abilities you have to solve a problem, the more likely you will learn. William James defined intelligence as being able to solve a problem in different ways. Spiders do that. They learn. Meanwhile, snakes hide, surprise prey, some wrap around them, but their only real weapon is poison, their venom. They don't have many ways to solve a problem. There's a critical difference between spider venoms and snake venoms. Although spider venoms are very diverse, they evolved from a single core molecule. The key is that this was a peptide, not a protein. That sounds complicated, peptide, not protein, but it isn't. You've heard that DNA makes proteins. Proteins make everything else. They catalyze the reactions that make fats and compose and configure carbohydrates. In other words, food pyramids show carbs at the bottom, but all this stuff is based on proteins. However, DNA doesn't actually make protein. It makes RNA, and RNA makes amino acids, and amino acids chain together long enough, chains make proteins. But amino acid chains that are too short to become proteins make peptides. Peptides are very active. They dissolve stuff or make things come together. They're unstable. They're not dependable. So they're not usually important in evolution. But spiders evolved a special peptide 400 million years ago. The peptide is knotted up by sulfur molecules. No matter how many mutations happened in this peptide, changing its impacts, its structure was held tight together. And spider venoms now have thousands of peptides, different ones, which over millions of years have mutated and diversified, but they all tie together because of this sulfur knot. And that's also interesting because sulfur is itself not very stable. Snakes, on the other hand, evolved 200 million years later from reptiles. And this happened after animals had gotten big and complicated, because all their special cells of animals needed various proteins. They had millions of proteins. So the reptiles recruited various proteins from their own bodies, proteins used for digestion, for inflammation, for other necessary functions. The reptiles that became snakes repurposed these into poison cocktails. Nature is opportunistic. Insects evolved. As soon as that happened, came the spiders that ate them. Animals evolved complex bodies with lots of different cells, with millions of different proteins. Reptiles exploited these and made lethal venoms. So lethal that those reptiles lost their limbs. which weren't needed to chase or hold prey or dig or jump. One bite and it was over. Spiders, on the other hand, had venoms that incapacitated prey. Spiders instead evolved incredibly complex silks. Orb spiders make 5 kinds of silk. One is very stretchable, one very stiff and solid, one follows the contour of what it's on. The most important is covered with glue. They shoot this at prey and it attaches to them so they can roll it up or hang it somewhere. Some spiders string a line of silk tight across a path. When an insect crosses it, it breaks, and a piece that's attached to the insect flings it out to the spider. Some spiders build triangle shapes out of silk. When an insect passes through, the shape yanks up and the prey is hung out to dry. Some spiders fly. Young ones will stick their rear ends in the air, release a thin silk thread, and it catches wind and they fly away. The spiders are complex characters. I don't know if you've had this experience where a spider is on a counter and you try to hit it, but it drops off the side of the counter attached by an invisible thread that spins out so fast you can't catch up and hits the ground and runs away. Snakes, they just slither, snarl, and spit. That's my view of spiders and snakes. And there's a moral. Never depend on just one solution or you'll end up slithering around. The more tools you have to solve a problem, the more interesting your life will be.